D flip-flop is usually drawn like this. It's got a clock, it's got a D, and a Q, maybe a Q naught. Truth table for the D flip-flop, we don't even have to worry about Q naught, right? We just need D and Q. So D and the clock are the input. You got two inputs, D and clock, and Q. The clock here may be a rising edge. What's our clock? Our clock looks like it's rising edge. On a rising edge, if D is 0, on the rising edge of the clock, the output Q becomes 0. Remember, these are in and out. And if D is 1, on the rising edge, Q becomes 1. And any other condition, it doesn't matter what D is. If the clock is not rising, if it's level or falling, we'll just draw falling. Q becomes Q. It's the same. It doesn't change. Right? No change. And D is my favorite, really super simple 1-bit memory circuit. Right? You put a value in, you clock it, and it remembers it. Clock goes low, or anything else happens over at D, it doesn't matter. The output remains the output. It remains unchanged. So the way the shift register works is we have our data comes in, and we have this clock. So here's the serial clock, and the serial clock is wired in parallel on every one of these registers. Don't worry about these ones on the right now. Don't worry about these ones over here. We're just looking at these, right? And it looks like a lot of wires, but it's self-similar. So all we have to do is understand one, and we should understand the whole thing. Okay, so the serial clock comes in here, and here, and here. So they're all in parallel, right? All of these guys have the clock in parallel. Okay, and then there's a reset line. This reset one, it's in parallel to every one. But if it's not low, so it's an active low, if it's not low, the reset doesn't do anything. Right? So we could ignore this reset for the purpose of understanding. And then the other one that we're concerned about is the serial data that comes in. So when the data comes in, say we have 1 bit coming in, and it's sitting here on D. As soon as we clock the clock, whatever's on D is copied to Q. Whatever was Q previously was sitting at this one, and so at that same time when it clocked, the value that was in this register shifted down and is now in this register. And the next time we clock, so let's say we start out like this, right? There's a bit here, we clock, and now that bit is here, right? We clock again, that same bit moves down here. We clock again, it moves here. We clock again, it moves here. We clock again, it moves here. Let's say we shifted in 1 bit, we clock again, and I shifted another bit. We clock again, clock again, clock again, clock again. So every time you clock, the data shifts down 1 register, and that's why they call it a shift register. If you clock this thing 8 times, if you clock the data through 8 times, you'll have 8 unique bits on each output of this shift register. Now the second step over here, it's another set of D flip-flops, and all the clocks are in parallel again. They're all in parallel, but the data comes from the Q of the preceding flip-flop. Right? So the data here hooks up here, hooks up here. When this register is clocked, all the data that's on this first set, so we've clocked these in one at a time, right? Now there's 8 bits sitting here. And when we clock that other register, all 8 bits get copied over here at the same time. Right? So it does a parallel. So this is shifting stuff in serially, and then the other clock does a parallel move, and all of these 8 bits get moved over here simultaneously. And the reason for this double buffer chip here is that when you're clocking the data through, so we got 24 segments we need to light up, right? So we're going to have 3 of these guys cascaded together. So you're going to have 3 shift registers, and we're going to clock 24 times. So the data that clocks in here, it's going to go all the way through this one, out of this one, into the next one, out of that one, into the next one, and clock through. After we've clocked all 24 bits, in one fell swoop, we're going to copy all 24 bits to the output. If we didn't do that, if we didn't have that parallel shift, Parallel copy, as you're shifting the data, you're going to see your displays kind of twinkle, right? Because you'd be presenting the data on the LCD.